Well, it's been a long time since I built any electronics, but finally I have found some time to play again. This is a board design and build video. So this project is to design and build a little minimal ATMega32U4 board where almost every part is optional. I call it MicroMin 32U. I use KiCad for board design, and if I get ambitious, I'll put the KiCad project up on GitHub so others can play with this. My first idea for the board was to just make a breakout board for the chip bringing out power and ground and all the GPIO to header pins, possibly to use on a breadboard. But seriously, you need to have bypass capacitors right next to the chip's power pins, so the board at its bare minimum would have the processor chip and bypass caps. Also, you need a pull-up resistor on the reset pin. You'd have to program it by the ICSP pins, which makes it a bit harder to program. You'd need an ISP tool or an Arduino acting as an ISP. That's the bare minimum. But this chip has built-in USB, so I wanted it so you could optionally throw on the required 2 resistors and USB connector. Now you'd only need to use the ICSP pins to program the USB bootloader. Then it's more like a normal Arduino type board. Reset would be on a header pin, but I wanted the option of putting a reset button on the board. Also, what would an Arduino style board be without an onboard LED to flash? Since this chip is used in the Arduino Leonardo, I wanted to put the LED on the same pin as expected for a Leonardo. And by the way, to program this in Arduino IDE or Platform IO, you would burn the Leonardo bootloader to the board, and then you can specify Arduino Leonardo as the hardware for a sketch. If you buy the right version of this chip, it can come with fuses set to use the internal RC oscillator for the system clock out of the box. So that makes it easy to make putting a 16 megahertz resonator on the board optional. In fact, all these options amount to just leaving parts off the board for the features you don't want. Let's look at the schematic. First, here is the ATmega chip and all the bypass capacitors. It has a pull-up on the reset pin and a 3-pin header for a jumper, so you can either pull up, pull down, or float the HWB pin. That pin is used for certain reset options that you can configure in the fuses. Here's the reset button. I used one available on Mouser. It's a bit large, but I have a bunch of them. Here is the LED. I also have a bunch of these green LEDs and an online calculator said to use a 100 ohm resistor. Here is the resonator. Very simple. Just hook up to the 2 X-Tal pins on the chip and to ground. Now here is the USB connector. There is more going on here. For one thing, I always put a 1 amp resettable fuse in line on the power line. Basically, if you use this with breadboard circuits, there is a good chance at some point you might short power to ground. This should keep things from generating smoke. If you don't want the fuse, you could hand solder a wire to bridge the pads. Notice the 222 ohm resistors on D plus and D minus. This comes from the data sheet for the ATmega chip. And finally, I always put a nice 10 microfarad electrolytic capacitor on the 5-volt supply. You could leave that out if you think it's excessive. Finally, the header pins. All the GPIO go to header pins and also power and ground, so you can get USB power to the breadboard, or if you aren't using USB, you can apply your power supply to those pins. Warning, don't do both. There's no protection to prevent you having 2 power sources. Finally, I have D plus and minus on the header as test points to be used in initial testing of the board. Here, let's take a look at the PCB layout. I packed things as tight as possible because my PCB fabricator charges by the square inch, and I want this to fit on a single standard breadboard. Here's the 3D view of it. I think it looks nice. I sent the board out to get a PCB and solder stencil. Takes a long time to get the boards, but I'm starting to play around with milling my own. Of course, only for 1 and 2 layer boards. I made this board 4-layer just to make routing easy. Note the mouse bites. I had to smooth those off. The first thing I do when putting the board together is to bring up the bill of materials. Get a piece of paper and draw a square for each part type. Label the squares with the part number, and then put that on a tray. Next, I pick the parts from my supplies and set them in their squares. Now is the time to find out you need to order a part, not after you've already put paste on the board. So I have all the parts. It's time to print the solder paste onto the board. Sometimes I 3D print a holder for the board, but in this case I just taped everything down to my work surface. Here's how the printing came out. Looks perfect to me. Now with tweezers and under a microscope, I carefully place the parts. After a few minutes in the reflow oven, I inspect the board for solder bridges. I don't see any. Now I check for shorts. Here is my technique. First, for the main chip, I check for adjacent pins bridged in this way. I note any bridges and then check every header pin against every other pin like this. On the main chip solder wick is a quick way to clear any bridges. Once I'm convinced there are no shorts, I connect to a USB power supply. I check for plus 5 volts on the header pin and check D plus and minus for reasonable levels. If that checks out, it's safe to go ahead and burn a bootloader. You have some options as far as how you burn the bootloader. One is to take another already working Arduino or compatible board and upload the Arduino ISP sketch to it from the example sketches in Arduino IDE. Follow the instructions for wiring and get a Blink sketch up and set it as a Leonardo with Arduino as ISP as the programmer. Then click on Burn Bootloader. I've done that, but find it a little flaky, probably because I have a cheap Arduino Uno clone as the programmer. The other option is to use a hardware ISP tool. In my case, I have a PicKit 5 ISP, not supported by AVRDude, so using Arduino IDE is not an option. Instead, I use the MPLAB X IDE and grab the Leonardo bootloader from Arduino IDE. If you do this, you must set the fuse bits the way the bootloader expects or USB bootloading won't work. Just know that all ICSP programming headers are is just SPI plus reset, power, and ground. All those pins are on the header. Once it has a bootloader, it becomes a nifty little Arduino compatible board. That's all for now. Thanks for watching.